you can enter critical section. So this one is enter critical section. So even though turn value has the problem, because of flag, you can enter, you can decide the next available. So this Harrison solution is a combination of algorithm 1. Algorithm 1 is using key, turn value. And plus algorithm 2. Algorithm 2 is checking the status of each process. So using this, the status, so either flag is a J, okay, the other. If the other is not using, or turn, okay, then we can enter the critical section. So this is the first synchronization problem solution that satisfies with the requirement. So 2 shows that the mutual exclusion definitely is yes, because the algorithm 0, algorithm 1, and algorithm 2, both of them are okay for the mutual exclusion. Then the process, the progress and the bounded weighting, because we address the limitation of algorithm 1 and algorithm 2. Even though, for example, turn is set to other value, because of flag, we can decide the next one. And also same thing for even though flag is not, so we can decide. To check whether this is really true, you can actually check all the possible cases. So why don't you take a look at all possible cases, whether it is okay for the progress and the bounded weighting. So Harrison solution is the first synchronization solution to satisfy with the 3 requirements of the synchronization. Problem? This is still 2 process cases. So it's in terms of algorithm, this is a simplest algorithm to understand synchronization solution. But this is for only 2 process cases. So that is a limitation. So to address that problem, we are going to extend the algorithm. Okay. The former. Okay. That is the software solution. We are using only the algorithm of this one and this one. Just add a few more instructions to check who will be the next or voting process and the exit section. However, this is a programming base. So operating system run additional code. It will be overhead because of each and every case instruction check whether enter the critical section. In case critical section, we need to run the entry section, exit section. Most of the entry section is what? While loop. It's called the busy waiting. So you are doing something, but it's just the waiting while you are doing something. It's instruction are executed a lot. So it's overhead to your system. Overhead of your system. To address that problem, why don't we use the hardware solution? Hardware means, in the computing architecture, hardware means instruction level. So we are going to use the instruction level. So basically, any synchronization solution is based on the what? It's a locking, kind of a locking problem. So if you get the lock, then you can do it. Because when you get the lock, that means there might be no problem to access the shared data. So we will consider such a synchronization solution as getting the lock and release the lock. In terms of the hardware, so we are going to use the interrupt. As we discussed several times, nowadays operating system, they are communicating what the request is up through the interrupt. So which means if you disable the interrupt, this cannot enter critical section. They cannot do anything. So disable the interrupt, then run the critical section. Then if you are done, release the interrupt. The benefit of using such an interrupt is because interrupt is the automatic. You cannot stop in the middle of interrupt because it's an automatic process. Okay. For this one, we can use some of the hardware Okay, like getting the lock will lose the lock. This is one of the solution. Let me explain to this one. Test and set is the instruction. Okay, who provided? Who provide the instruction? User? User use the instruction. Programmer? It's a CPU company. So Intel, if you are using i5, the i5 has the definition of instructions that are available. And if you are using AMD, AMD has different set of instructions. Because of that, I'm using exactly the same computer, but only difference is CPU, which means you need to use the different operating system because they are using different instructions. So let's say CPU company provides such a test and set instruction. Okay, looks like a software code, but it's implemented in your CPU hardware. So it's an instruction. So input is what? Value. Output is always true. I don't just take a look at the input target. The input is Boolean. So for example, Boolean is the input is false. False. Target is true. Return RV. So false, but value is changed as what? True. So let's say this is the target. First, the target is false. If you input the test and set, output will be the same as this one, false. But target is actually changed to the true. This is a test and set instruction. So, however, in case of true, this is a true, also this is a true. Always it will be true. Output of instruction is false, but the value itself will be changed as this one. So we are going to use this. So we consider lock as the key, kind of to access the bathroom. So this is first nobody used false. So one process would like to access this one. What is the value of lock? False. What is the return of test and set? False. It's the same as the input. Then, what after this? Then this is a false. You can enter critical section, right? Then at that time, what is the value of lock? It's a change it always true. So if this moment, if somebody other process would like to enter the critical section, okay, what is the value of lock? It's a true. What is the output of test and set? True. So which means while loop, you cannot exit the while loop. So other process keep waiting. Okay. Then what about the process? Current process is done. This is an exit section. Exit is lock is false. At that time, if another process is accessing this one, lock is changed as false, which means output of test and set is false. So the other process can enter critical section. This may be the solution. What's the difference between algorithm 1 and this one? This is a hardware solution. Only one is atomic instruction. So it should be done. It cannot be shared. So it will not be shared. Okay? Different from the ton is a shared data. However, this one is not shared data. This is hardware. So it can be applied for the many process. What about the mutual exclusion? It's okay. And what about the progress? Maybe okay. It's okay because one of the process will get the lock. Okay? It will not be forever. It's not deadlock. Problem? It's for example, if 5 processes are waiting, running while loop, which one will be selected? We don't know. Okay? Maybe parser one of the process, waiting, cannot get the lock. Okay? So that is the problem. So bounded waiting time is not good in this case. However, this is implemented by what? Hardware level, very fast. Comparing to the software solution, it's very fast. Okay, so this is the hardware solution. Another, the solution is using swap. So we will talk about the swap and the other in the next class on Wednesday. I didn't have a time to do the quiz today. Maybe next the class we will. Any question? Please read the textbook. At least the slide to understand. It's not complicated, the everything, but if you, this is a very helpful for your even application programming. Okay, so thank you and see you on Wednesday.